Alright, welcome again to another lecture. In today's lecture, we're going to talk about the Babel sort. So Babel sort is a very famous algorithm in computer sciences, especially in sorting, okay, in the sorting field and sorting theory. We know that sorting is basically the idea of having an array or a container that has a bunch of elements, a bunch of numbers, that we want to sort them according to some criteria. So in our examples, we're going to consider arrays that has integers. But the same principle would work no matter what type of the array, as long as there's some criteria that we can use to compare its elements. So the Babel sort. Now the Babel sort is very popular because it's very, very simple to implement, and it's very simple to understand, and it's very simple to start with. So the idea of Babel sort is to compare every two consecutive elements, see if they're ordered or not. If they're not ordered, then we're going to order them, and then move to the next ones and order them, and then move to the next ones and order them, and so on and so forth. And we keep doing this until we're sure that the array is sorted. Okay? So here's an example. Let's say we have this array 0, 1, 2, 3, 4, 5, 6, 7, 8. This array with 9 elements. Let's say that the numbers are 2, 1, 3, 1, 4, minus 1, 2, 2, 6. And we want to sort these random numbers. So we would basically create a counter and a pointer that points to the very first element. And then that pointer we would always compare. Let's say that that pointer is called I, and this array is called T. So we would always compare T of I versus T of I plus 1. And then we increment I, and then T of I, and then T of I plus 1. And we increment I, and so forth. So we compare 2 to 1. So 1 is bigger than 2, so we flip them. So here we would have 1, and then 2. And then we move to the next one. We compare 2 and 3. They're ordered. So we move to the next one, 3 and 1. So they are not ordered, so we flip them. So it'll be 1 and then 3. Then we move 3 to 4. They're ordered. 4 and minus 1. They're not ordered. So we flip them. And then 4 and 2, they're not ordered, so we flip them. So this one becomes 4, and this one becomes 2. And then 4 and 2, they're not ordered, so we flip them. So here we would have 2, and here we would have 4. And then 4 and 6, they're ordered. And we keep repeating the same thing. 1 and 2, they're ordered. 1 and 2, 2 and 1, they're not ordered. So we flip them. 1 and 2, 2 and 3, they're ordered, 3 and minus 1, they're not ordered, and so on. So we keep doing this, Until what? Well, until we have an array that is sorted. Here's an example, here's a sorted array. How would we tell whether our array is sorted or not? That's the question. Now, every time we make a flip, every time we make a change in the array, we save that information inside a Boolean variable, okay? We tell the variable, oh, we made a change, okay? And whenever we repeat the whole process, that variable takes false, okay? So the variable initializes with false, and whenever we make a change, we make it true, and then whenever we repeat the whole process, we reset that to false again, okay? We reset that to false. Now, when we do not make a change, it means that the entire array is sorted. It means that the first element is less than the second is less than the third is less than the fourth, and so on. The n minus 1th element is less than the nth element, and so on. So if that's true, if we did not make any change, it means that this Boolean variable will remain false. It means that our array is sorted. Okay? So if our array is not sorted, then if our array is sorted, then we can stop. Okay, so let's write this idea. Let's write this algorithm. Let's try to replace this algorithm with some real code. So the first thing we would do is we would declare a variable, a Boolean variable. Let's call this sorted. Okay, and it initially takes false. Or let's make it takes true, okay? It takes true. And we're going to repeat we're going to repeat this operation. So we're going to do while sorted is false. As long as sorted is false, repeat this whole code. Make it true, do some stuff, and then check whether sorted is false. If it is false, repeat again. If it's not true, if it's not false, if it's true, it means that this is sorted, then we're going to quit. Okay. Now the content inside this repeating process would be to loop through the entire array and compare every element with the element just next to it, and if they're not sorted, we're going to sort them. So for I starts at the very first element at index 0 up to the very last element minus 1, so from 0 up to 7. So the very last element minus 1, so from 0 up to 7. And we basically go to 7 because every time we're comparing the element with the element next to it. So if we make it from 0 up to 8, then we're going to compare 8 with the element next to it, which doesn't exist. Okay, for that reason, we stop at not the very last element, but just before the very last element. Okay, so for I starts from 0 up to n minus 1, we compare if t of I, the element number I, is bigger than the one next to it. Okay, if the element number I is bigger than t of I plus 1. Okay, in that case, we would swap them. Okay, so let's say we have two variables. This is x, this is y, this has 2, this has 3. How can we swap these two variables? Well, we could create another temporary variable. We copy the 2 inside the temporary variable. Okay, so let's do that. So tmp takes t of I. That's our first variable, t of I. And then we would copy the y inside the x. So the y inside the x, so this becomes 3. So t of I takes t of I plus 1. Let's free up some room here. And then we would copy the temp back to y. So it'll be like this. So we copy the 2 to y. So originally we had 2 and 3, now we have 3 and 2. So finally t of I plus 1 takes tmp, the temporary variable. That's and if. And whenever we make this swap-in operation, we want the sorted variable to take false. So sorted takes false. And if, and then and for, and then while sorted equals false. Okay, so basically this is the algorithm of bubble sort. Okay, so let's try to code this with C and see whether it works or not.